All right, hello, welcome to a new video. This is for binary search 704 easy problem LeetCode. I'm checking my camera's good. It's good. All right, so let's go through it. So given an array of integers, nums, which is sorted in ascending order, and an integer target, write a function to search target in nums. If target exists, then return its index. Otherwise, return -1. Okay, you must write an algorithm with O log n runtime complexity. Okay, so I think it's pretty simple, but the implementation might be hard for me because I haven't done this in a while. But when the problem says sorted array, we typically use a binary search algorithm. So for our input, we're just given an integer named nums, and it's just an integer array. And then the output is just going to be, what is it? Is it the, wait, oh, the index, okay. Does it say the index? Oh yeah, return index. So index, which is also an int, and then to note that must use binary search to solve, and that the oh yeah, we're also given target. Oops, target index, and we can say that we can return -1 if return -1 if target doesn't exist, right? So that's pretty much it. I guess for some questions, I really want to know what the size of nums is, what the min size. And then I don't think the values really matter because it's in ascending order, so that's fine. So the min value of nums is 1. It's good to know. Um, and just to know it's in ascending order. Uh, okay, so let's go through some examples. For example 1. Wow, my throat is so dry. I've been doing interview practice for like 3 days now. Um, for like 2 hours a day. So yeah, we'll see how my voice is during the interview. Okay, so example 1. Let's just say that nums, it's in ascending order, right? So let's do 1, let's do an easy 1, 2, 3. Okay, so and our target is obviously going to be 2, right? So, um, so we're going to return index 1, right? Because binary search left and right, and then what was it? And then middle. So left and right, then calculate middle, and then yeah. So yeah, that's interesting. So let's do example 2. This is a warm up for my binary search too. So binary search is kind of weird during when it's even. So let's do an even one. So 1, 2, 3, 4, and our target is still 2, right? So obviously it's going to return 1 still, but let me just review it. So 1, so left, right, middle is 0 plus 3 divided by 2, so that's 1. Then middle is equal to, oh, okay, yeah, okay. I think there's like a edge case, but we'll see. So example 3, let's make it bigger. Actually, let's just make it even, but have it at 4, right? So target's 4, so it's gonna obviously return index 3, but let's see how it works. So left, right, left, left plus right divided by 2, so 3 divided by 2, that's 1, right? And then think middle is less than target, so we move left to middle, I think. Middle plus 1, I don't know. This is probably a good thing to review actually. So it's good I'm doing this. Because I searched it up in one interview like 5 years ago said that they did a binary search problem. So yeah, that's why I'm doing this. So that's good. So we'll just see how I plan it out. So we're also going to use binary search in a while loop and if statements. And then so binary search consists of left, right, and middle. And yeah. So let's go ahead and get started. So plan, initialize pointers. So left, right. And I don't think I can do middle. Maybe I calculate middle and for loop equal to 0 and then length of nums minus 1. And then binary search. So right, so do a while loop. So while left is less than equal to right, because left can equal to right. We're going to calculate middle, so calc middle. So it's calc middle, we just do left plus right divided by 2. And then from there, we see, so base case is like if m is equal to, if m is equal to target, then return m. In other words, if m, oops, if num's at m, my bad. And then if num's at m is less than target, then I think we move left to the right. Yeah, we move left to the right. So I think L is equal to m plus 1. I think that's, or is it m equals to 1? Oh, I don't know. And then right stays where it is. And then if it's a case where else 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 it's more than, then we just say L right is equal to n minus 1. And then I think that should work. Yeah, I think that should work. Because if it's not m, yeah, if it's not m, then we just skip over it, right? So that makes sense. So now, let me think. Yeah, I think that's pretty much it. And then just return -1 outside the while loop, because if we can't find it in the while loop, which means if we can't find it during binary search, then that means the target's not there. So yeah. So I think this plan is good. All I know is that the implementation might be weird, but I would like to kind of go over the implementation. Let's just go through it right now before we implement it. So let's say we want to find 2. All right, so left is right here, right is right here. We calculate middle, so 2 divided by 2, that's 1. So 1's right here. The index 1's right here. And then we check if the middle value is equal to target value, and it's true, so we return index 1. And here, left is right here, right is right here. Our target is 2. So we calculate the middle. So the middle is 0 plus 3. So that's 3 divided by 2. That's 1, which is right here. Let's make it interesting. So let's say target's 3. Right, target's 3. So we're at 1, and then okay. So if we're at 1, and at index 1, the value is 2. So 2 is less than 3. So our left is going to move to right here, m plus 1. And then now we're going to calculate middle again. So left plus right indexes, that's 0, 1, that's 2 plus 3. So that's 5 divided by 2, that's, wait, 5 divided by 2, that's 2. So middle is 2, right? Here we see that the index value at 2 is 3, and 3 is equal to the target, so we're going to output 2. And in this case, left is right here, right is right here. We do 0 plus 3. 0 plus 3 divided by 2, so 3 divided by 2. That's 1. 1's right here. Middle is less than our target. So we're going to increment our left to n plus 1. So n plus 1's right here. So then we do um, we calculate the middle. So 2 plus 5. That's 5 divided by 2. That's 2. The target value, the index value at 2 is 3. 3 is less than target, so we move left to n plus 1. So n plus 1's right here now. So now we have left plus right, 4 plus 4. I mean 3 plus 3 divided by 2, so 6 divided by 2, that's 3. And then so index value at 3 is 4, and target value at 4, I mean target is 4. So 4 is equal to 4, which means we found the target, and we will turn index 3. So it does work, which is good. So let's go ahead and kind of, I think, it does work in my head, so let's just do it, man. Like, send it. All right, so let's go ahead and implement this. So, and we need to initialize, we're gonna follow plan. So, initialize pointers. So left, right is equal to 0, and length. I'm so tired right now. Length nums minus 1. Then we do the binary search. So while left is less than equal to right. We calculate middle. So middle is equal to left plus right, integer divided by 2, and then say if nums at the middle index is equal to target, then return m. If that's not the case, then if nums at m is less than target, then I'm going to say that the left, we're going to move left to the right, and then else then we move right to the left, and then we're going to, out of the while loop, we're going to turn -1 if that doesn't work in the while loop. Accepted. Accepted. Let's go. All right, so RNG, I got beat. So whatever. um, yeah, very, very swag, very cool.